All right. Hey you guys. Today we're going to be doing, well, the next couple of days we're going to be getting into some trigonometry. I'm going to be doing things like sine, cosines, and tangents. I'm going to be taking a look at different angle measures, learning about coterminal angles, arc measures, and things of that nature. So we're getting into some new stuff for these next few days. First I have some pictures up here. Let's go through and just reminisce about angles and things of that nature. So we know all kind of different types of angles. When you make an angle, you have an initial side, which is made of this ray. You have a vertex, and then you have another ray. So this is called your initial side, and then the other side is called your terminal side. Now we're going to be going in a counterclockwise direction. So we're going to be starting with our initial side and then going over to the left in a counterclockwise direction. So the bottom ray is your initial side, and then the other side is your terminal side. Angles in standard position look like this. So we're going to be transposing our angle on the XY axis and introducing this idea of a unit circle. Again, this is still your initial side that I've darkened here. The other side is your terminal side. And your angle direction, we are going to be going over to the left in a counterclockwise direction. When you go in a counterclockwise rotation, it's a positive angle demonstrated by this picture. And when you go in a clockwise direction, that is a negative angle. So kind of maybe backwards from what you think it might would be. But counterclockwise, if you start on the initial side and rotate over to the left, that's going to be counterclockwise, and that's positive. And if you start at your initial side and rotate to the right, that's actually going to give you a negative angle value. So these are just some pictures as we get it, slowly work our way into some different type of angles. Normally we work with angles in degrees. Normally we work with our angles in degrees, but today I'm going to show you about a new type of measurement called a radian. So a degree is 1/360th of a full rotation. So we know that because there's 360 degrees in a circle. So 1 degree must be 1 fraction of that. So 1/360th. There's something also called a radian that we can measure our angles in. The measure theta, so this is theta, it's a circle, kind of like a little curvy measure in it, so that we're going to be using that for our angle measure. So this is called theta, no different than an X or a Y or a Z. This is just a representation of our angle. The measure theta in radians of a central angle of a circle is equal to the ratio of the length of the intercepted arc, S, to the radius R of the circle. So down here in this picture, theta is my angle measure. I don't know if theta is 30 degrees, 50 degrees, 11 degrees. We don't know what that is. S here is called our intercepted arc. So we did talk about that a couple of weeks ago. That is our intercepted arc. And R is the radius, which we know is halfway across the circle. So a radian is going to be another type of way that we're going to measure our angles. So we're very comfortable with degrees, 57 degrees, 100 degrees. I'm also going to show you about radians. So let's go ahead and jump into that. And I'm going to show you how to convert from degrees to radians and then radians to degrees. So you do want to jot this down. Okay, so pause it, write it down, whatever you need to do. And now we're going to go through it and we're going to pick some problems that are in degrees. We're going to translate those to radians. And then after we do that, we're going to go from radians to degrees. All right, so here's the first way. So first we're going to go with what you're comfortable doing. You're comfortable with degrees, 60 degrees, 270 degrees, 45 degrees, 120 degrees. I'm going to show you how to convert these angle measurements that are in degrees to this new word today called radians. So it's another way of still measuring our angle. When you're going from degrees to radians, you're going to multiply by pi over 180. So I'm going to take each of these and multiply by pi over 180. So this is our conversion factor. When you're going from degrees to radians, you are going to multiply by pi over 180. So all of these are going to get multiplied. So I'm going to go ahead and set that up because that is going to be our conversion factor for every single one of these. So that is our conversion factor. When you're going from degrees to radians, you multiply by pi over 180. Now what we're going to do is simplify our fractions. So when you multiply, you do top times top and bottom times bottom. So this is going to give me 60 pi over 180. Now, 60 and 180 can be reduced, so we definitely want to reduce this. So 60 over 180 becomes 1/3. So 60 over 180, feel free to type that in Desmos, becomes 1/3. So my answer is pi thirds. So we started out in degrees, which we're comfortable with, and now we have a new way to measure the same angle, and it's in radians, and that is pi thirds. Again, this was 1/3. No need to put this 1 in the numerator. It's understood to be there. I'm going to go through and do the same thing. We're going to multiply top times top and reduce. So 270 over 180. 270 over 180 is going to reduce. Feel free to type that in Desmos. It reduces to 3/2. So now I have 3 pi over 2. So 270 degrees is the same as 3 pi halves. I'm going to go through and do the same thing here. 45 times pi over 180, and we're going to reduce our fraction. The more of these you do, you won't have to write this intermediate stuff in. You'll just be able to go ahead and reduce as necessary. 45 over 180 reduces to pi fourths. And when I do this one here, 120 times pi over 180, we need to reduce 120 over 180, and that is going to reduce to 2/3. So this is us going from degrees to radians. So we are going from degrees to radians, reduce, reduce, reduce. So same angle, like same point on our picture that we're looking at. If I pull this back up for a minute. So we're still going to be ending in a certain same spot. We're still going to be ending in the same spot. It's just one conversion is in degrees and the other is in radians. So just two different ways of measuring the same spot that we ended up at. Now I'm going to go through and do the opposite. So this time I'm going to go from radians to degrees. When you're converting from radians to degrees, you're going to multiply by 180 over pi. So it's the opposite conversion factor. So 180 over pi. I'm going to go through and go ahead and write out all my 180 over pi's. And 180 over pi. So I went ahead and just put our conversion factor. Now, your pi's should cancel because pi 9 times out of 10 is going to show up in a radian angle measure, but our pi's are going to cancel. So hopefully that'll help you remember your conversion factor because I have a pi in the top and I have a pi in the bottom that is going to cancel. So pi on top, pi on bottom is going to cancel with all of these. So again, hopefully that'll help you remember your conversion factor. So now this just becomes 180 over 6. And 180 over 6 is 30 degrees. So pi over 6 is my angle measured in radians. And this is my angle measured in degrees. I'm going to go through and do the same thing. 5 times 180 and then divide it by 6 is going to give me 225. And I apologize, 5 times 180 and then divided by 6 is going to give me 150. I was looking at the wrong problem there. That's going to give me 150. So again, I did 5 times 180 divided by 6. This one is 5 times 180 divided by 4. This is the one that's going to give me 225 degrees. And then 8 times 180 divided by 3. Absolutely, you can use Desmos, and it'll give you 480 degrees. Okay, so let me see if I can figure all these out in same all together. So all 8 of these. So when you're going from degrees to radians, your conversion factor is pi over 180. When you're going from radians to degrees, your conversion factor is 180 over pi. Now, I'm going to introduce something to us. It's called a unit circle. Unfortunately, we don't have time to dive too deep into it, but we're just going to kind of like work our way around it nice and slow here. So what I've done is I have some degrees down here, and I've already converted these degrees to radians. So I've taken 270, 360, 180, and 90, and I've already converted those to radians. So that gave me 3 pi halves, 2 pi, pi, and pi halves. So now I'm going to put these on a circle, and then I'm going to show you what the unit circle actually looks like. So we're working our way towards this idea of a unit circle. So I've drawn some circles here, the kind of, look kind of ovalish, but work with me. I've drawn some circles here. We're starting here. This is going to be our initial side, and we're going around the circle counterclockwise. So we know that there are 0 degrees here. If you go all the way around, there's 360 degrees in a circle. So this first circle, I stopped at 90 degrees. This second circle, I stopped at 180 degrees. That's in the black. This third circle, I stopped at 270 degrees. And this fourth circle, I went all the way around the circle. So we are starting here. That's my starting point for all of these. And we are going counterclockwise around the circle. 90 degrees, I did 180, I did 270, and I did 360. In the red, I've gone through and I put those angle measurements in radians. So 90 degrees is pi halves, 180 degrees is pi, 270 degrees is 3 pi over 2, and 360 degrees is 2 pi. So there's 2 pi radians in a full rotation. There's 360 degrees in a full rotation. So we're working our way towards this idea of a unit circle. So real quickly, I'm going to put this up here, and I'm also going to include a link in here if you're interested in learning a little bit more about the unit circle, since we're a little bit pressed for time. This is the unit circle. What has happened is we took sine functions, cosine functions, tangent functions, and we took right triangles and we put those inside of our unit circle. So I'm just going to highlight the degrees for right now and not too much the numbers because I don't want to confuse you. But notice here's the 90 degrees that we just did, and it gave me pi halves. Notice when I go around half the circle, it's 180 degrees, but it's also pi. When I go 270 degrees, that gives me 270 degrees, obviously, but in radians, it's 3 pi halves. And then one full rotation is 2 pi. So that is just a little quick touch on something called the unit circle. We're going to get into arc length, and then I probably will revisit that unit circle in a few minutes. So let's talk about arc length. Okay, so you do want to write this down. Arc length, if theta is a central angle in a circle of radius r, then the length of the intercepted arc S is given by the following. So this formula is S equals R times theta. So that is our formula. S equals R times theta. So we're going to be using that, and we're going to go through, and I have some circles, and we're going to be finding the arc length of the circle. So this is my formula. S is the arc length. R is the radius, and this is theta. And we're going to be using this to find the arc length of our circle. So this picture earlier that I pointed out to you about what I told you, this was the intercepted arc, this was the radius, and then this was my angle measured in radians. Same thing. This is the formula that we're going to be using to find precisely what that is. So I got 3 examples. All right, first one. So I know that my radius is 5. My angle measure is 5 pi over 6. So the first thing that I'm going to do is write our formula down. So we're going to be looking for the length of our intercepted arc. So we're looking for the length that I'm somewhat highlighting in red here. So this from here to here, we're looking for the length of that intercepted arc. We need to know what our angle measure is in radians, and we need to know what my radius is. So in this particular problem, it's just a matter of substituting my numbers in. We know that 5 is the radius, and we know that theta has to be measured in radians. It's 5 pi over 6. So I just substituted my numbers into the formula. So I can multiply this out. I can get a decimal answer or a precise answer. So I'm going to put both of those for you. So 5 times 5 pi is going to give me 25 pi over 6. So that's my exact answer. 5 times 5 pi gives me 25 pi over 6. Or if I want it as a decimal, I would type that in, and I would get the following. So these are my answers. Now let's take a look at one that does not give us the angle in radians, but it gives it to us in degrees. So number 2, I'm looking for the length of this intercepted arc here. Let's start by writing our formula down. Now, I got my radius as 12, but this is given to us 30 degrees. We need to find it in radians. So somewhere off to the side, we're going to do a little conversion factor here. And I'm going to do that in this blue color. So 30 degrees, I need to convert that to radians. So my conversion factor is pi over 180. When I multiply this, 30 pi over 180, reduce it, 30 over 180 reduces to pi over 6. So pi over 6 is what I need to substitute into our formula. Do not substitute it into degrees. It has to be in radians. So this is going to give me, my radius is 12, and my angle in radians is pi 6. Okay. We go through and multiply this. This gives me 12 pi over 6, which is 2. Okay. Because 12 divided by 6 gives me 2, and as a decimal, it gives me the following. Okay. Let's go through and try one more. So number 3, I'm looking for my arc length around here. So what I highlighted in red there, let's start by writing our formula down. I know the radius is 8, and this is given to us in degrees. It's 135 degrees. We need to do a conversion factor, so I can do that over here to the side. My conversion factor is pi over 180. When I multiply this and simplify, I get 3 pi over 4. So conversion factor is pi over 180, reduce your fraction. 135 over 180 reduces to 3/4. So when I'm substituting into my formula, my radius is 8, and my angle in radians is 3 pi 4ths. We go through and multiply this. This gives me 8 times 3 is 24, divided by 4, this gives me 6 pi. And as a decimal, it gives me 18.84. And I should be putting my units for all of these. So all of these were centimeters, centimeters, centimeters. So that is arc length. Arc length is S equals R times theta. So S equals R times theta. Now let's do one of these problems in like a word problem form. We're still using the formula. It just may be written a little differently, so I don't want you to be intimidated by that. So the minute hand of a clock is 6 inches long. How far does the tip of the minute hand move in 15 minutes? How far does it move in 25 minutes? So let's write our formula down. I need to know the radius of such clock, and I need to know my angle measurement in radians. So the first thing I'm going to do is I see in the problem, it says, how far does the tip of the minute hand move in 15 minutes? So I need to figure out what portion of my clock, what portion of this circle idea that we've been working towards today, what portion of it is 15 minutes. So 15 minutes, I'm going to do some scratch work off to the side. 15 minutes out of 60. So that's 15 out of 60. If I reduce that, that gives me 1/4. So 15 over 60 reduces to 1/4. Now, earlier we saw that 1/4 is pi halves of the circle. So let me go back to my picture that's down here at the bottom. This is 1/4 of the circle. This is a fourth, that's a fourth, that's a fourth, and that's a fourth. So 90 degrees is 1/4 of 360, but we're using radians today. So instead of using 90 degrees in radians is pi halves. If you ever forgot that, you could just multiply this by 2 pi, because that's how many that's how many radians are in a full rotation. So I'm going to take this 1/4 and multiply by 2 pi. Once we do that, that gives you pi halves. So pi halves is what we're substituting into our equation, and that is going to be my angle measure. The radius is 6 because it says up here the minute hand of a clock is 6 inches. So my radius is 6. And my angle measured in radians is pi halves. 6 times pi halves gives me 3 pi inches. So that gives me 3 pi inches. And I also had a part 2. It wants to know about the 25 minutes. So I will go through and do the same thing for the 25 minutes. I'm going to see what portion of the circle 25 minutes is. So I could do 25 over 60. Once you do 25 over 60, I got, you're going to take that and you're going to multiply by 2 pi. So I'm doing the same thing that I did up here. You're going to convert this, simplify this, and multiply by 2 pi. Once you do that, you get 5 pi over 6. So I did do a step in my head. Reduce your fraction, like how I reduced up here to 1/4. Reduce this fraction. You don't really have to, but it might help if you're doing like your mental math. Or you can use Desmos. So I'm doing 25 over 60. I'm going to multiply by 2 pi and reduce your numbers. It gives you 5 pi over 6. So this time my formula. My radius is still 6. And we'll plug in 5 pi over 6. The 6's cancel out, and we're left with 5 pi. All right, one last thing I want to do today, but I'm going to do that in the second video. We're going to talk about coterminal angles.